second friction lab for the week. First, let's talk a little bit more about friction. So as we said last time, friction is resistance of an object sliding over another object. So friction is anything as simple as, this tape measure sliding over here. There's friction. There's resistance to that movement. Same thing with your hands sliding across each other. And friction usually generates heat. In the last lab, we looked at the different levels of roughness and how that affects friction. And that's all sliding friction. Remember from your lecture that there's a couple of different types of friction. So sliding friction is the friction of just something moving across a surface, just sliding across a surface. Now, if I took this book and I just set it here, that's static friction, remember. It's not moving at all, but there's still friction there. It's in contact with something else. And if I want to start it moving, if I want to change that inertia, then it's going to be some friction involved there. So this is static friction. This is sliding friction as we're moving across here. In today's lab, we're going to be looking at the difference between sliding friction and rolling friction. So let's look at what the lab has here. So first, you've got your lab sheet, your assignment sheet is in Teams for you to look at. I've got mine printed out here so I can just follow right along with it. You should have in your notebook or a sheet of paper, you should have your data sheet set up. Looks like this, 2 rows, 2 columns. Again, this is my desk since I don't have a nice smooth surface out here in the shop that's going to function as my desk. And then the other column, of course, is the rollers. If you want to do this at home, I'm using pieces of dowel that's cut to 5 inches or so. You could do this with Bic pens, the round stick pens. It can't be like a pencil where it's a shape like a stop sign. They can't have flat sides all over it, otherwise they're going to be too much friction and it won't roll. So there's got to be something that's completely round like this, or paper towel rolls or anything like that. All right, so setting up the lab. All right, we've made our data table. That's our step 1. Step 2, set the large book on your desk. Here we have a very large book, teacher's edition of some science book. Slide a string through the center of the page so equal amounts of string hang on both sides. So I'm just laying the string through the book and I'm shutting the book. And so now I've got roughly equal amounts of string hanging on both sides here. Step 4, attach the string to a rubber band. So we could do this a couple of different ways. I'm going to tie the strings off just so I have a closed loop here. And now I'm just going to take my rubber band and I'm going to loop it on itself so that it is now connected to the string. All right, and then a little adjustment here so we're even. All right, so what we're going to be doing is pulling this and seeing when it's going to move. This book might be heavy enough that that's all we're going to need. The directions say now put a smaller book on top, but these are really heavy books, so I'm not sure it's going to work. Let's see if this is going to happen without breaking. Yeah, okay, we'll be okay. All right, I'm putting the books back at the very edge of the table here, so that'll be my start point. Put the second book on top of the first. That's step 5. Step 6, pull the rubber band slowly. It says runner band, sorry. It is rubber band slowly until the books start to move, and we're going to mark that. So I'm going to take my marker, and I'm going to be ready to mark that when it starts to move. All right, here we go. I got my rubber band, string through the book. I got both books. Brace the table here because it's on wheels and it wants to roll. All right, starting to move, and I'm right at the edge of the dry erase board here. So now I can measure that. So from the end of my string to the edge of the dry erase board, we've got 14 3/8. So in my data chart at desk, I'm going to write 14 3/8 inches. If you want to call it 14 1/2, that's fine. All right, now we're going to change this up a little bit. And I'm going to put these rollers under. I don't want them jammed tight against each other, but try to get them spaced out just a little bit. That just doesn't cooperate, it can't play. All right, books are on the rollers. I'm lined up again on the back edge of the... So we've got our books up on rollers now. I've got the rubber band. Whoa, steady on, steady on. You can kind of see how this is gonna go. All right, and let's see as soon as we start getting some motion here. All right, right here. You can see how absolutely effortless this is to move across there. So rolling friction is incredibly efficient. All right, I'm back to the starting line. And I'm measuring from the end of my string, just like I did last time, out to where my finger is, and I've got about 5 inches. So now in my data table, I'm writing 5 inches down for the rollers. Your job is to write down your observations and then write down your conclusion. Why is it that the rollers, I only needed to stretch this for 5 inches, and when I'm just have it down on the desk, I'm stretching for 14 3/8 inches. Why is it so different? Don't just tell me that the rollers make it slide easier. I want to hear stuff about friction, what you know about friction that tells me that this is the case.